Alright, so let's take a look at section 4.4. Okay, this section's a little bit different than the rest of what we're going to do. I put this section in here because it's kind of an easier section, so at least if there's some of these questions on the test, it'll kind of balance out some of the harder questions. So the way I will do the test this week is half the material is going to be on what we do today, half the material will be on what we do Tuesday, Wednesday, Thursday. Okay, so it'll be 50-50, even though we're only going to spend one day on this section. Alright, so we're going to start by just looking at that diagram. And the section is about area of a triangle. So let's just start off with the formula you already hopefully know from geometry. Anybody remember the formula for area of a triangle? Yeah, Ryan?
The base times the height.
Yeah. It's 1/2 base times height. And that formula works great as long as you know the base and the height. But if you had a triangle like this, let's say this was 100 degrees, this was 6, and this was 10. Well, you know the base, you could look at the base as 6, but you don't know the height. Okay, the height would be if you were standing up at the top there and dropped something straight down, how far down would it go? That's the height. Okay. So if you don't know the height, somehow you got to figure out the height. Hey, any questions on that formula? 1/2 base times height. All right, so in my triangle, B represents the base. The dotted line that's perpendicular to the base is the height. And I've labeled two other things, A and gamma. Okay, so I'll come back to that diagram. We're going to use that to figure something out. All right, so we just wrote down the formula. 1/2 base times height. I think most people remember what the B and the H stand for, but if you don't, that's what they stand for. And the whole reason we're looking at what we're doing is because if you don't know the height, we're going to use a different formula. And to figure out that formula, we're going to use the diagram that I had up above. So you can do your calculation if you have room next to the diagram, or you can do it down below like I'm going to. Either way is fine. So the goal is going to be, looking at the diagram we just had, a formula for the height. Okay, because we don't know the height, it's a dotted line, we're going to figure it out. Okay, any thoughts on how we could figure out the height? Okay, I might need to label one more side. Let's label that C. I'm not sure if we'll use it or not, but I think you might end up using it. I'll give you a hint. It's going to involve a trig function. Somehow it's going to involve a trig function. And now that I'm looking at it, I don't think you're going to need the C. Not for the way we're going to set it up. Okay, I want you to think about using just those three things. Well, let's start with the names of those sides. From the perspective of gamma, what's the name of the side that's labeled H? Should it be opposite, adjacent, or hypotenuse? Trudy? Yeah, it's opposite, right? Because it's across from gamma. So let's keep that in mind. We have opposite. And what about A? That's the side across from the 90. So what side would that be in the triangle? It's not opposite, because that's H. It's the hypotenuse. So we're using opposite and hypotenuse. Does anybody remember the trig function that has those two? Yep. Cosine has adjacent and hypotenuse. Sine. Yep. Sine has opposite and hypotenuse. All right, so let's scroll down. And we're going to start with sine of our angle. Peter, what's the name of that angle that we're using?
Gamma.
Yep, sine of gamma equals, and now you're going to put opposite over hypotenuse. H over A. H over A. Now my goal is to get H by itself. Okay, I'm trying to get a formula that says H equals. Okay, Paige, how would I get H by itself there? Yep, multiply both sides by A. Multiply both sides by A, and there's a formula for H. A sine gamma equals H. Now, what I'm going to do is just take that, make this a little smaller, and I'm going to plug in what I have for H right there in for H. So I'm going to still keep 1/2 B, 1/2 the base, but instead of writing H as the height, I'm going to write A sine gamma. That's the height. Right, so using right triangle trig. Okay, so that's what I just said I'm going to do. Plug in A sine gamma for the height. And that's what you get. You get 1/2 B, or 1/2 the base, times A sine gamma. Now you have four things you're multiplying together there. 1/2 times B times A times sine gamma. When you multiply, does it matter the order you do it in? No. Like if you had 2 times 3 times 4, if you did 4 times 3 times 2, you get the same thing. So the way that you usually see this formula written is in alphabetical order, 1/2 AB sine gamma. But if you do BA, that's the same as AB. Okay. Any question on that? So that's the formula for area of a triangle if you knew sides A and B. Now, let's draw it. Let's look at it. A, B, C. And we'll label alpha, beta, and gamma. Okay, so look at that formula. Look at the two sides you're using, A and B. Look at the angle you're using, gamma. Where is gamma in that triangle compared to the two sides, A and B? Anybody? Oh, Connor, do you see that? Where is gamma compared to the two sides in this formula, A and B? Yeah, it's A and B are the two sides of gamma. Right? Side A is one side of the angle gamma, side B is the other. So we can also write that a different way. Okay. If I wanted to write my formula using, let's look at it this way first. Sine alpha. Okay, keeping in mind what we just said, what two sides do you think I would use if alpha was the angle? Rudy?
B and C.
B and C. Yeah. So it's not a different formula, it's just the other two sides. Okay, now let's look at it for beta. If I was using beta, can anyone else tell me what two sides you think I would use there? Well, Alex?
C and A.
Yeah. A and C are the two sides of the angle. So you'd use A and C. So in general, it's easier to just remember the idea of what you're doing rather than try to remember every arrangement of letters. Because if you remember the idea, you can do it with any arrangement of letters, not even A, B, and C. You could use X, Y, and Z for the sides. So in general, the formula, if you wanted to summarize all of those, it's 1/2 the product of the two sides times the sine of the angle between the two sides. Okay, so 1/2 the product of two sides, any two you want, times the sine of the angle that's between the two sides you picked. Okay, and another reason that's important is because if you're given a diagram, they might not label the sides A, B, and C. They might be blank. Maybe they'll look something like that. Find the area. Well, now you don't know which side is A, which side is B, and which side is C, but it doesn't matter. Okay? As long as you know the concept behind the formula. Okay, so this gives you another way to find the area of a triangle. Still based on the idea that it's 1/2 base times height, except you use trigonometry to find the height, and that's built into the formula. You don't have to go through and think about opposite over hypotenuse. It's already built in for you. That's what the sine is. Okay, any questions on that? Okay, a couple different ways they could give you a problem like this. One way is they give you a diagram and just have you find the area, or they just give you information and have you find the area. Now, it's always a good idea to sketch it to make sure the information they gave you is the information you need to do it. If they didn't give you the two sides and the angle between them, you're going to have to figure something else out. So let's sketch it. Okay, you can sketch it any way you want. The only requirement is A across from alpha, B across from beta, C across from gamma. So I'll do A across from alpha, B across from beta, and then that leaves that side is C across from gamma. And gamma, I know I can label that. Gamma is 30. Again, I know that doesn't look like a 30-degree angle. It's not to scale. Okay. Okay, so Emily, did they give me the information that I need here, or do I need to figure out something else?
What do you have everything?
Yeah, I have everything I need. I have the two sides, and I have the angle between them. Now, let's say they did something like this. Okay, don't write that down. I'm going to put it back the way it was. But in that case, they didn't give me what I needed. Okay? So we would have to do a little bit of work to figure out that angle. Okay? And that's where you could use law of sines or law of cosines. Okay, we've done that. But in this case, we don't need it. Okay, anyone think they can, you don't have to give me the answer, but just set up the calculation for the area of that triangle. Well, Zach, could you start us off with the formula?
A equals 1/2 8 times, no, 6 times 8.
Yep, you could do 8 times 6 or 6 times 8. It's either way, it's still going to be 48. So he's got 1/2 the product of the two sides times, and then one more thing.
Sine.
Yep. Half the product of the two sides times the sine of the angle between them. All right, so we've got 8 times 6, that gives me 48. And then half of 48 gives me 24. Sine 30. Now at this point, you have to type that in on the calculator, and see what you get. Okay, double check that you're in the right mode. Okay, all of these problems will be in degrees when they give you the angle. There's no reason you couldn't do it in radians. We just don't. Okay, and anyone get an answer? We'll just round to 2 decimal places. Yep, Rudy? 12? Exactly 12? Okay. So 24 sine 30. If it's exactly 12, then that means the sine of 30 must have been 1/2, which is something we did way back when we did unit circle trade. Okay, all those values. So we get 12. And now because it's an area, how many dimensions is area? Is it 1-dimensional, 2-dimensional, 3-dimensional? How much? 3-dimensional would be volume. Yeah. 2. So whatever the units are, you should put square units. If it's inches, square inches. I don't know what the units are, so I'll just put some units squared. 12 square units. Okay. Any questions on that? Okay, when you do need to round, 2 decimal places should be sufficient. Okay, so this is a problem where a couple things are different. One, you know the units, so keep that in mind for the final answer. And 2, you don't know what side is A, B, and C, but it doesn't matter. Okay. Just keep in mind the general concept of what you're doing. All right, so let's try this. So Robin, you think you could start us off with the formula to find the area?
Sorry, it's Monday morning and you.
It's all right. Monday after Thanksgiving, it's rough for everyone. What do all the formulas start with? What number?
1/2.
They all start with a half, right? Just like you're taking the area of a triangle using the old formula, you always start with 1/2. And now, anyone else tell me what's going to come after the 1/2? Molly?
3 times 4.
Yeah, we're going to do 1/2 the product of the two sides times the sine of the angle between them. And Alex, what's the angle between them? 30. Now, given the last problem, we already know the sine of 30, so we should be able to do this in our head. Okay. 3 times 4, Cameron, what does that give me? 12. And then half of that?
6.
And then half of that again? 3. So that's the area of the triangle, 3 square inches. Any questions on that? All right, and I'll give you one to try on your own. This time the angle, it's an angle that's not going to come out nice. Okay, so when I ask you to do it, just round it off to 2 decimal places. All right, let's take a look at how to set this one up. Emily, you don't have to give me the answer, but can you just tell me what the formula would be to find the area?
1/2 5 times 2 sine 20.
Sine 20. Yep. And if we want, we can cancel that right away because half of 2 is 1. So now we just have 5 sine 20. Okay, and at this point, we're going to type it in and then round it off to 2 decimal places. Okay, so Connor, what did you get when you typed that in? 1.7. Can you give me one more decimal?
1.71.
1.71. Anyone else get 1.71? The area? Perfect. Anything else, Connor, you should put with that number? Just so we know what that number represents.
Oh, R1.
What does it represent? It's or it's an. Like that, what is that 1.71 about this triangle? It's an area, yes. So what should I put on that number so we know that it's an area?
Something squared.
Something squared, yeah, we don't know what it is in this case. The last problem, we knew it was inches, so just put square units. Good. Any questions on that? All right, so let's try one a little different. We can still do it using the formula that I just showed you. But this time, the information that they give you is all the sides. Okay, so you can still find the area, but what are we missing? What are we missing here that you would need to know in order to use the formula we just wrote down? Yep. An angle, which one? You want to tell me which angle would you have to know there? Yeah.
One between 4 and 5.
The one between 4 and 5? That would work. Anything else? Any of them. It doesn't matter which angle you know. You just have to know one of them. Okay. Either the one between the 8 and the 5, the 8 and the 4, or the 4 and the 5. Find one of them. Okay, now, in order to find the angle, there's two laws we learned about, law of sines and law of cosines. Does anybody remember which law you had to use for side, side, side? Remember which law? This was not last week, but it was the week before, so it was a little while ago. But well, anybody have a guess? And while those people are looking up the formula, hopefully we're going to need whatever formula we need to use in a minute. So keep looking for the formula if you haven't found it. Yeah?
Is it cosine?
It is. It's the law of cosines. So use law of cosines to find one angle. Doesn't matter which angle. So law of cosines was the formula. There were three different versions of it. Okay, it wasn't the law of sines where you have the three fractions. Okay, sine of alpha over a, sine of beta over b. That's law of sines. Does anybody remember what the law of cosines kind of looked like? It started out looking like another formula. Yeah? Right, it starts out looking like the Pythagorean theorem. So does anybody have the law of cosines? They can give me any version of it. It doesn't matter. That's just going to control which angle we solve for. Yeah?
C squared equals a squared plus b squared minus 2ab cosine gamma.
So it's one side squared equals the sum of the other two minus twice the other two cosine of the angle across from what you started with. Okay, so let's just fill it in and see what we get. Okay, so C is 5. So I'm just going to square it as I go. So 25. And then I have 64 plus 16. Okay, what's 64 plus 16? 80. Minus 2 times 8 times 4. Well, 2 times 8 is 16. What's 16 times 4? 64 cosine gamma. Now, this is the step that some people mess up order of operations here. What would be my next step to start getting the cosine gamma by itself? Yep.
Subtract the 80 from both sides.
Right, you cannot do 80 minus 64 because the 64 is multiplied by a variable. But you can subtract 80. Subtract 80. 25 minus 80 is going to give me negative 55. negative 55 equals negative 64 cosine gamma. That's not a good looking gamma, but. Okay, how about, Ryan, what would my next step be? Well, what are you trying to get by itself?
The cosine.
Well, we want the variable by itself, right? Eventually, that's the thing we want all by itself. So what's the variable here?
Is it gamma?
Gamma. So there's two things that are preventing gamma from being alone. One is the cosine. What's the other thing?
The negative 64.
Yeah, let's focus on that. Okay, the function we can't get rid of till the very end. But the negative 64, we can move to the other side. So on the right, you've got negative 64 times cosine. So what would be the opposite of times? Divide. You're going to divide each side by negative 64. That's going to cancel the negatives and the 64. Negatives are gone. Okay, don't even worry about what 55 over 64 is. Just leave it. So 55 over 64 equals cosine gamma. And now what's the last step to get gamma by itself and get rid of cosine? Okay, so this is where we cannot add, subtract, multiply, or divide. We've got to cancel cosine somehow. Yeah,
Take inverse cosine.
exactly. Take the inverse cosine of 55 over 64. And that's the answer for gamma. And then once we have it, now we can do this just like we did the last couple problems. Second, inverse cosine. Okay, and you should get about 30.75. Okay, so that's gamma. Can somebody tell me where gamma is on that triangle? Just to make sure we know the right spot. Yep. Across from C. Bless you. Okay, here's C. Bless you.
Thank you.
What did I say it was? 30.75. And there's your angle. Okay, now we can set up the formula to find the area. A little bit more work because you had to figure out an angle first. They didn't give you the right information to just plug it in and go. Okay. So Matt, can you tell me what my formula for the area would be here?
1/2 8 times 4
Yep, 1/2 8 times 4.
times 30.7.
Exactly. So let's just do the first part. I usually do that if it's nice and you can do it in your head. What's half of 8 times 4?
16.
16, yep. Again, the angle's in degrees. Make sure your calculator is still in degrees. We're going to type that in, round it off, and see what we get. Okay, anybody have an answer for that once you type it in? Yep, done.
8.18.
8.18. Okay, how many other people got 8.18? Good. Let's go back up. All right, looking at the way the side lengths were measured, Zach, can you tell me what I should label that? 8.18? Yep. So that's square footage. 8.18 square feet. Okay, any question on that one? All right, so not too bad, but if you had to do that over and over, where they gave you a problem with all the sides, it would be a lot easier if you had a formula that you could directly use to find the area of a side-side-side triangle without having to use the law of cosines every time. Okay? Kind of like a formula where the law of cosines is already built into the formula for you. There is. So there's nothing wrong with the way we just did it. It will work. And we got the right answer. But An easier way to find the area of a triangle, where you know all the sides, is Heron's formula. If you don't want to have to remember another formula for the test, then don't worry about writing it down. You don't need this. Do it just like this. But if you want an easier way to do it, even though it's an extra formula to remember, here's an easier formula. Okay, and if you look at that at first, you might be like, well, wait, where's the law of cosines? How is what we just did built into that formula? And you just have to trust me that it is. If we were to prove where this formula came from, we would use the law of cosines to figure this formula out. If you look at the proof in your book of this, it's kind of long, which is why we don't go through it. All right, so there's a couple different letters here. I'm going to hope everybody already knew what A, B, and C were. Those are the sides. Have we seen S before? Is that a letter that we've used with triangles? No. We haven't used S. Okay, well, S, even though it's a new letter, it's not a very complicated idea. S is just what you call the semi-perimeter. Okay, what is the semi-perimeter? You take the perimeter and divide it by 2, or take half of it. Okay, so to find the area of a side-side-side triangle, you need 3 things. The 3 sides, and then you need the semi-perimeter. Any question on Heron's formula? Okay, let's try it. All right, let's you know what? Let's do example 3 again. Let's do the same sides, and let's check if we get the same answer with this formula in the way that we did it. Now, because of rounding, it might come off, a little bit off. You might get 8.17 or something like that. Right? But let's do sides of 4, 5, and 8. Can somebody remind me, to use Heron's formula, what's the one other thing we need to know besides the 3 sides? We also need, Ryan? The semi-perimeter. Which is just the perimeter divided by 2, or take half of it, same thing. Okay, so if you add up 4, 5, and 8, you get 4 plus 5 is 9, 9 plus 8 is 17. 17 divided by 2. 8.5. Now, I'm not worried if you label that as inches or feet. We don't even know it here, but if we did, you don't have to label that because that's not the final answer. All right, so let's find the area. Okay, Victoria, what's the first thing I start with in Heron's formula? And help her out. What's the very first thing that's under the square root? Well, I guess the first thing you start with is the square root. I already did that for you. So square root of, first, S. Bless you. We have S. And then the next thing, Alex, what were you gonna say 8.5?
Yeah.
Yep. Can you tell me the next thing that comes after that?
8.5 minus 4.
So 8.5. So S minus A. Can you give me the next factor? Hayden, do you think you know the next factor?
8.5 minus 5.
Yeah, 8.5 minus 5. And Rudy, the last one?
8.5 minus 8.
Yeah, so it doesn't really matter. You just have to remember that you have S, and then you have times S minus every side. It doesn't matter what order you do it in. Just do s minus the first one, second one, and minus the third one. Great. So the first part, I think all the subtraction, we should be able to do that in our head. So we have 8.5 times, Ashlyn, what's 8.5 minus 4?
8.5 minus 4 is
4.5. Katie, 8.5 minus 5?
3.5.
3.5. And Mason, what about 8.5 minus 8? A half. All right. Now from here, we got to type that in and see what we get. We already know what we should get because we just did this problem using law of cosines. Okay, we should get about 8.18. Let's check and see what we get. So we have 8.5 times 4.5, 3.5, and 0.5. I already put the square root in, so it's already there. And we get exactly what we did doing it with law of cosines. 8.18 square units. Unless they told me the units, which they didn't. Okay, so I'm just giving you a different way to do a side-side-side triangle. Not necessary to do it this way, but you could. Okay. Any questions on that one? All right. Take a second. Let me switch the numbers up a little bit. I think that's the one we just did, 5 and 4. Yeah, so let's do some different numbers. Let's do 7, 6, and 3. Now I could just pick any numbers. Does anyone remember what I have to make sure of in a triangle if I want the problem to actually work? Any two sides added together have to be bigger than the third. So like if I pick 7, 6, and 1, you're going to get a negative area. Something weird's going to happen. Okay? Okay, but that should be fine. Okay, so take a minute and see if you can find the area of that triangle. Okay, so let's take a look. First thing you want to do is find the semi-perimeter, because we don't have it. And anyone tell me what the semi-perimeter would be here? How much? Yeah, it's going to be 8. 6 and 3 gives you 9. 9 plus 7 is going to give you 16. Half of it is 8. Technically it's feet, but again, that's not the final answer, so I'm not concerned if you label that or not. All right, so area equals square root. Now you always start with s, which is 8. Now normally we do s minus a, s minus b, s minus c. But we don't know which one is a, which one is b, and which one is c. Is that a problem? No, it doesn't matter because you have to do s minus every one of them. So do them in any order you want. S minus the first, s minus the second, s minus the third. So the area is going to be the square root of 8 times 1, which you don't need that one, times 2, times 6. All right, so the square root of 8 times 2 times 6, and then we're going to just round that off.
Times 5.
5, thank you. All right, so 8 times 2 times 5, so it's the square root of 80. And that's technically exact. Now we're rounding. Anyone give me what the decimal comes out to for square root of 80?
8.94.
How much?
8.94.
8.94. It has to be a little less than 9, because 9 times 9 is 81, so that's very close. So the answer should be just a little smaller than 9 in square feet. Any questions on that? 8.94 square feet. All right, so the last one we're going to look at is finding a formula for a special kind of triangle, okay, specifically the area of an equilateral triangle. Now, you could use Heron's formula, or even the first formula I taught you, to do an equilateral triangle. But if all the sides are the same, there's an even faster way to do it. Okay. So when you do S minus A, S minus B, S minus C for equilateral, they all come out the same. So why would you do the same calculation 3 times in a row? There's got to be a faster way. Okay, and there is. Right, so let's just label this as a generic equilateral triangle. All I know is all the sides are the same. They could all be 2, they could all be 6, whatever they happen to be. Right. Now, let's use Heron's formula and find the area of that. Only difference is we're not going to have a numeric answer. When we're done, we're going to have a formula. And we'll have a formula for the area of an equilateral triangle. All right, so we know the 3 sides are all x. What's the perimeter of that triangle if you add up all the sides? Alex?
X equals 3.
For perimeter?
Oh, well, couldn't you just use the original 1.5 x times height?
We don't know the height. The height would be right there. We don't have that line that I just drew labeled. So we've got to use Heron's formula, but I need the semi-perimeter first. So let's just start. What's the perimeter? Yeah?
3x.
3x. So what's the semi-perimeter?
3x divided by 2.
3x divided by 2. Or you could just write 1.5x. If you want to think of it that way, that's the same thing. 1.5x. So let's plug it into Heron's formula and see what we get. I'm going to use the 3/2 version instead of 1.5 because it'll make the arithmetic easier to do in my head. So area equals square root. Peter, what's the first thing we put?
3 over 2x.
Yep. S times. And Connor, what would come next? Yep, exactly. 3 over 2x. So S minus a side. And what would come next? Same thing again. 3 over 2x minus a different side. And what would be next? Same thing again. 3 over 2x minus a third side. So let's combine like terms there, because each one of those is 1.5x. Take away 1x. We can combine that. So 3 over 2x times, what's 1.5x take away 1x? A half x. So each one of those things in parentheses is 1/2 x. So 1/2 x, 1/2 x, 1/2 x. And this is where we're going to start to be able to simplify it and not have to write the same thing 3 times in a row. Okay. All right, so what I'm going to do is I'm multiplying everything that's under that root. 3/2 times x times 1/2 times x times 1/2 times x times 1/2 times x. So rather than have it number, letter, number, letter, number, letter, all the way down, let's put number, 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 letter, 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 letter. We'll regroup it so the like terms are next to each other. So that number times that number times that number times that number. So we've taken care of multiplied all the numbers. And now multiply all the letters. X, 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 x. Okay. Any questions on that stuff? Now we can combine all those into a single fraction just by multiplying straight across the top. What's 3 times 1 times 1 times 1? 3. Divided by 2 times 2 times 2 times 2. 16. So 3/16. And then x times x times x times x. That would be x to the fourth power. Okay. So now we can simplify that even a little bit more by taking the square root of everything. Okay. Or what we can. Okay, some of it will simplify, some of it won't. So to take the square root of all that stuff, do all three things separately. Square root of 3 divided by square root of 16 times the square root of x to the fourth. Square root of 3, I can't really do much with that. How about the square root of 16? When you take the square root of 16? 4. There's the square root of 16. Times, and what would be the square root of x to the fourth? What is it? Yeah, because x to the second times x to the second is x to the fourth. That's the definition of a square root. What can you multiply by itself to get x to the fourth? X to the second. And that's the formula for the area of an equilateral triangle. Usually they write it like this. X squared, square root of 3 over 4. So that's the area of equilateral triangle. So it's kind of it's a shortened version of Heron's formula. Okay. It's Heron's formula where all the sides are the same. Okay, so let's finish up by using that to find the area of an equilateral triangle. Now, this problem that I'm showing you, you have 3 ways to do it now. The slowest way would be to draw it out. Well, actually, in this case, it wouldn't be that slow, and I'll ask somebody why in a second. Find one of these angles, which actually wouldn't be that hard, and then use the first formula I taught you. Or, second formula is just to do Heron's formula. Do the whole thing out. The third way is to use the formula we just went over. X squared, square root of 3 over 4, where x is the length of the side. That's what we started with, x, and x. Now, I think we're going to try using the formula we just did. But how come finding an angle here wouldn't be that bad? You wouldn't need to go through law of cosines and all that stuff. How come? Yeah?
So maybe the same.
They're all going to be the same. It's an equilateral triangle, so what would all the angles be?
60.
They're all 60. So technically, you could find an angle very quickly and just do this problem the first way. But let's try our formula. Okay, so the area is the side squared times the square root of 3 divided by 4. And just simplify what you can. So 64 square root of 3 divided by 4. And what's 64 divided by 4?
16.
16. Yep. So we got 16 square roots of 3. Now, if they don't tell you, you can leave the answer just like that. The area of that triangle is 16 times the square root of 3, whatever that number is, square units. If they wanted it done out, just type that in on your calculator, and that's the answer. All right, so in terms of usefulness, which formula do you think is more useful? The formula we just went over, area of an equilateral triangle, or Heron's formula? which one is more generally useful? Which one? This one? You think this one's more useful? How come? All right, so not which one is quicker, because that's a different question. This one, I agree, is quicker than Heron's formula for this problem. But which one is more useful? Which one can be applied in more situations?
Turns.
Why?
It's not only for equilaterals, it's for all triangles.
Exactly. This formula is only for equilateral triangles. You can't use it for anything else. So it's a very specialized formula. We could come up with specialized formulas for everything. We could come up with a specialized one for an isosceles. We could come up with one, you could come up with as many special formulas as you want. But we're only going to do equilateral because that's a common one. Isosceles would be another common one. But those aren't as universally useful. Okay? So Heron's formula, very useful. The first formula I showed you, very useful. This one, although very quick, not as useful. All right. So that wraps up everything we're really going to do today with area of triangle. Last thing I'm going to show you is just kind of a preview of what we're going to do today and tomorrow, because I know some people were kind of nervous about it. And I'm going to show you a problem, and maybe you won't think it's as bad as some people might think it is. So, and you know what? I'm actually going to do something even easier. I want to look at this. That's the kind of problems we're going to look at. They're going to give you something and just ask you to simplify it. That's all. Simplify it. And there's different tricks to simplifying, but for this one, I'm just going to show you one thing. I'm not even going to write it all down formally. But my hint, and I'll write this tomorrow, is going to be to change that all to sines and cosines. Does anybody remember what function you flip to get secant? Because we don't have a secant button on the calculator, but if I asked you to do secant, you take this trig function and flip it. Anybody remember which one you flip? Yep.
Cosine?
Yes. If you flip the cosine, you get the secant. Does anybody remember which function you flip to get the cosecant? Right? You flip the sine. Okay, and I'm going to remind you of all these formulas again tomorrow. So what I'm going to do is I'm going to take and change that to what we just said. Change secant to 1 over cosine. That's the top. And change cosecant to 1 over sine. That's the bottom. Now, when you have a fraction divided by a fraction, okay, kind of like this. How do you divide two fractions if they were just numbers? Good? You multiply by the reciprocal. Take the one in the bottom, flip it, and multiply by what's in the top. So let's do the same thing. Take the one in the bottom, flip it, and multiply by what's in the top. So the top was 1 over cosine. I flip the one in the bottom, I get sine over 1. Now multiply straight across. What's 1 times sine? Sine. Cosine times 1. Cosine. Now, does anybody know what sine divided by cosine is? That reduces to a very nice thing. Let me go back to this for 1 second, and then I think you'll know what it is. When we did unit circle trig, okay, just watch this part. Sine was y, cosine was x. Does anybody remember what tangent was? Yeah? It was y divided by x. Okay? Y divided by x. Y divided by x. Y is sine, x is cosine. So if you take y and you divide by x, what do you get? Tangent. This is tangent. It's y divided by x, sine divided by cosine. Okay? And I'm going to write that down tomorrow. But that's the idea of the problems we're going to look at this week. Okay? You just try to simplify something they give you as much as you can using that. We just use substitution right there. Substituting. Okay? So if you think that's not too bad, that's basically what we're going to do the rest of this week. Problems like that. All right, so homework tonight, it's just on area of a triangle. There's no trig identities. We're going to save that for Tuesday, Wednesday, Thursday. So on page 280, 6 to 16 even, 20, 22, and 33. I gave you a hint on number 33, because at number 33, they want the area of this blue section. Well, the only way to find that is to find the area of the red section, which goes all the way back to what we did in week 1. There's a formula for it. So look up the formula for area of a sector. And then if you can find the red section and subtract the green section, you'll be left with just the blue section. So the green one you should be able to do from the formula for today. The red one, you're going to have to look back first week of class to get the formula.